Hello, we are group number 9, Miners Designs, and we will be doing the teardown analysis of the BakTrack blood alcohol detector keychain edition. And I'm Christopher Vega.
I'm Savannah Bryce.
I'm Esther Lee.
And I'm Keenan Middleton.
So let's go ahead and dive on in.
So the product includes this breathalyzer and 3 little mouthpieces. So if you look on the product, we have a little keychain right here for easy transportation. You can put this on your keychains or on your purses, your belt loops. It'll work either way. Then right here we have the mouthpiece. It goes up and down really easily. And one of these mouthpieces actually fit on, just so. Oh, yep, like that. Real simple and easy. And then on the side right here, we have a single button. When you push it, the device has a countdown timer so that it lets you know how long it has to do before it can warm up. So when it gets to 0, you have to breathe into it as much as you can. But if you don't, the breathalyzer knows that it's not getting the proper input it needs. So it's just going to be quiet. And eventually it'll give you a fail output. So see, there you go, FL for fail. So that's how you know that you didn't do something right or the device didn't detect the things it needs. And then, yeah, right here on the back we have a little place for the battery. It's really easy to put in and out. It's a AAA battery. And there you go. So we're going to have the test subject right here. Go ahead and use the device. You just push that button on the side right there. And as I said before, it takes a while for the device to warm up. But once it gets down to 0, you have to be sure to blow into the device. Of course, the mouthpiece is optional, but if you don't want to contaminate yourself. So that prolonged beeping means that it's working. And as you can see, our subject has a 0 BAC.
Alright, so we're going to start out with the dimensions of the device. The width is 1.4 inches, the height is 2.75 inches, and the depth is 0.75 inches. We're also going to measure the mouthpiece, which is 1.5 inches. Alright, so we're going to start taking apart the device. All you need to take it apart is a simple screwdriver. And here we go. Oh, there you go.
There it is. Alright, so now that our device is actually taken apart, we can see this front panel with this little small piece of clear plastic here that allows the LED screen to be displayed. We have our 2 screws that we're holding it all together, and our back panel for the battery, which you can see should go right in this area. And so taking a closer look at our mouthpiece, we can see that whenever this part opens up here, then it actually exposes this small little hole that allows air to pass over this sensor and out the back of the device for accurate readings. And then once again, once it's closed off, no air is allowed to go into the sensor and it is able to be maintained. And then down here we can see we have our external button, which actually pushes onto this internal button and just keeps it isolated from the outside, and then that starts our overall process.
Alright, so this is the inside of the device. Right here you have the sensor, and right here you have the LED display. This is a 10 volt RVT right here. It's a field effect transistor with a regular voltage threshold. This right here is a pot for calibration, and this is the internal button that when pressed from the outside it'll cause the whole loop of the timing and then breathing in the air. This is the 5-lead SMD package. It's going to act as a boost converter because some aspects of the device need more voltage than the 1.5 volt battery provides. This is another 10 volt RVT field effect transistor. You have the power input right here where the negative side of the battery goes, and the power output where the positive side of the battery goes. You have an inductor right here and a diode right in the middle right here.
Alright, so moving on to the back of this circuit, once it's been flipped out like so from this back panel, we start over here with this speaker, which is used for when collection of the data starts and while it's actually going on. We get that long beep going on. Moving down here, we have our Holtec 8-bit microcontroller, which is actually like a mini CPU for this entire device. The Holtec 8-bit microcontroller has the possibility to store memory, has a built-in timer function, and 63 other optional instructions. It also has 3 operating modes, including normal, slow, and sleep. This device utilizes the normal mode and the sleep mode for its operation. Now, moving along over here, these small black rectangles are the transistors that are used in the overall circuit, and then these small silver dots here are resistors and capacitors, which are used for the overall operation. And then moving along still, we once again get back to our sensor and our power input and our power output.
The MQ303A alcohol sensor consists of a 100-mesh network, gas sensing layer, metal casing, base, and electrodes. Air moves across the sensor, which is made of tin dioxide that reacts with ethanol from the breath in order to change the resistance. Prior to measuring the breath, the sensor needs to heat up for 13 seconds. Then, when ethanol moves across the heated sensor, it reacts with the tin dioxide and pulls out oxygen molecules from it. This will lower the overall resistance of the sensor.
It's important to use the device during room temperature or at a normal humidity. For if there's a large enough amount of gas of butanes, hydrogen, or ethanol in the atmosphere, that will influence the sensor and cause a lower resistance than what it really is, and thus give a higher BAC reading than what it really is, and thus give a false results.